In this video, we're going to be looking at the law of definite proportions, also referred to as the law of constant composition or Proust's law. They're all synonymous for the same concept. This law states that a compound is always composed of the same proportions of elements by mass. Now, that definition may be a bit wordy, so we're going to break it down by using examples. On the left, we have carbon dioxide, and on the right, we have carbon monoxide. What's similar about both of these compounds? They're both constituent of the same elements. They're both made up of carbon and oxygen. That's what makes them pretty similar. So what we're going to do is we're going to see the proportion in which carbon and oxygen are combined to make each of these compounds. As you can see by the definition over here, the proportions of elements by mass. So we're going to make it so we have carbon, sort of like a ratio in a way, carbon to oxygen. All right, and for carbon dioxide, we'll do that one first. So carbon dioxide has a molar mass of 12 grams, so we're going to use that, 12 grams. And oxygen has a molar mass of 16 grams, but we have 2 atoms of oxygen for every compound, so we're going to have 32 grams. Right, so since this is a ratio, we can simplify this further, and if you divide, you can get 3 into 8 as the ratio. Awesome. Let's do the same thing for carbon monoxide. So you have carbon to oxygen ratio, and you know that the molar mass of carbon is still going to be 12 grams, and for oxygen it's 16 grams, but we only have 1 oxygen for every compound, so it's going to be 12 to 16 grams. And as we did here, we can simplify this further by making it 3 into 4, and that's going to be the ratio here. Now, what's really important here is that this ratio of carbon to oxygen is what makes this element carbon dioxide. It is unique, it is proprietary to this particular compound. The same thing for this. Even though they're made of the same elements, this ratio and the way that they're proportionately put together is what gives this substance, these substances, their respective identities. Right, so like you think of it as like an ID in a way. If carbon dioxide were to go to the bar, they would ask for this particular ratio. And to say carbon dioxide, grew up and the ratio became 6 to maybe 16, that's still going to simplify to 3 into 8. Right, so say you had like a mass which was 6 to 16, that's going to simplify to 3 over 8. So that constant ratio is constant, if you see what I'm saying there. As long as that ratio is constant, this substance is going to be carbon dioxide. And the same thing for carbon monoxide. If you found that a compound had a ratio of 6 to 8, or maybe 9 to 12, right, it's going to code down to carbon monoxide. You can simplify it. So you know that if the compound had a carbon-oxygen ratio of 9 to 12, it's going to be carbon monoxide, because this ratio is what makes carbon monoxide carbon monoxide. All right. Let's do some example problems to further illustrate this. Okay, in this question, a pure sample of water is said to have 85 grams of hydrogen. Assuming there are no impurities, what is the mass of oxygen present in the sample? And we're going to use the law of constant composition or definite proportions, whatever you want to call it. We're going to use that concept to help solve this question. So first of all, let's write the chemical formula for water, and it's going to be H2O. And we can use the law of definite proportions by looking at the proportions in which hydrogen and oxygen are combined to make water, because that will be a unique proportion. So let's do that. So you have hydrogen ratio to water, right? And you know that hydrogen has a molar mass of 1, so you have 1 plus 1 because there's 2 of them. So you're going to have 2 grams. And then for water, for oxygen, it's going to have a molar mass of 16. So you're going to have 2 to 16 grams. And this can be simplified to 1 to 8. So for every 1 gram of hydrogen, you're going to have 8 grams of oxygen. That is the proportion in which hydrogen and oxygen are combined to make water. Okay, and we know that the pure sample of water has 85 grams 85 grams of hydrogen. We can use this proportion as a conversion factor almost, or like a percent or some kind of ratio to convert from hydrogen to oxygen. So we know that we have 85 grams, and we also know that for every 1 gram of hydrogen, there's going to be 8 grams of oxygen. So what you can do here is quickly solve this equation. The units here of hydrogen are going to cancel out, so you'll be left with your answer in terms of oxygen, the mass of oxygen in grams. So if you just do 85 multiplied by 8 is going to give you 85 multiplied by 8 is going to give you 680 grams. 680 grams. Awesome. So hopefully that made sense. We just use this proportion here as a conversion factor to convert from grams of hydrogen into water. Let's go to the next question. Okay. If 2.85 grams of ammonium contains 2.34 grams of nitrogen, first calculate the mass percent of nitrogen, and then calculate how many grams of nitrogen would be present in 2,000 grams of ammonium. Okay, so the first part of the question asks for the mass percent. And we can calculate that quite easily. It's asking for nitrogen's mass percent. So what it's going to be is it's going to be mass of nitrogen over, sorry, that was a very unstraight line, over mass of the overall substance, which in this case is going to be ammonium, right? So this is just going to be 2.34 over 2.85, and we're going to multiply that result by 100 to get a percent value. So this is very similar to taking the proportion. However, we're just taking it for nitrogen, and we're going to make that into a percent. So 2.34 divided by 2.85 times 100 should give you 82%. 82.1% by mass of nitrogen. All right, and now the question asks how many grams of nitrogen would be present in 2,000 grams of ammonium. Well, this relates to the law of constant composition because this mass percent of nitrogen is going to be proprietary to the ammonium compound. So we can just use this as a conversion factor. In the previous one, we used a fraction. Here, we're using a percent, same concept, and we're going to use that to find the mass of nitrogen present in 2,000 grams of ammonium overall. So this percent is sort of proprietary to, this mass percent of nitrogen is going to be proprietary to the compound of ammonium. So that's why we're able to use it. It's very, very similar to the previous question where we used a fraction instead. So let's do that. So we have 2,000 grams here, grams of NH3. And there's no need for fractions here because you have the mass percent, so you can just multiply it straight up. So you're going to get 0.821%. And then that's going to give you your mass of nitrogen. So you're going to get 2,000 times 0.821. That's going to give you 1,642 grams of nitrogen. All right. So in this video, we looked at the law of definite proportion or constant composition. We looked at what it is. We looked at some examples over here, and we did some practice problems. If you enjoyed the video, please consider subscribing to the channel, like the video, and I look forward to seeing you guys soon.